Hello, everyone. Welcome back to SAT Math Question of the Day. Here's our question of the day. Please read it, pause the video, try it, come back, and we'll do it here. Okay, here we go. We have a figure. Which of the following statements must be true? Okay, let's check them out. They're asking about parallel lines. C is the midpoint. I don't think so. Maybe. Triangle CBA is congruent. Not likely. AB angle ABC and DCE are vertical angles. Well, I don't think so.
What is remind me? What is a vertical angle? What is it when
these are vertical? I was just going to do it. These are vertical angles. These are vertical angles. When two lines cross, the angles opposite each other are vertical.
Oh,
angles.
okay.
So these are vertical angles.
Yeah.
But since we know all this, we might as well put in all the.
Yeah.
It's tempting. It really is tempting to put in all the angles. This is 135.
Yeah, so let's put in all the angles. So we use the fact that the sum of the angles.
I think we have
angle A plus angle B in the triangle.
Yeah. All
plus
the angles
angle C in that triangle equals, add up the measures of the angles, and you always get 180 degrees.
Right.
So we could figure these out. Yeah. To get 180 degrees by adding these things, we get 10, that's 10, 105 and 45 gives 150. Therefore, 30.
Right.
We check that out. And then notice there's a 45 here. These two angles are 45 and 105. These two angles are also 45 and 105. So that's 32. So the two triangles are similar.
The two triangles are similar. That's not one of the choices, but they are giving us the choice to say that these two lines are parallel. And you can say yes, they are, because those alternate interior angles, this angle and this angle, are equal. When you have parallel lines, if these two angles are equal, these things are called alternate interior angles. Then the lines, if those angles are equal, then the two lines cut by that transversal that makes those angles is parallel. Those two lines are parallel. So that would be that's right, alternate. So that means one can then conclude that the two lines are parallel. So I think that's it, right?
Yeah.
Once you calculate,
I'll write out the other pair of alternate interior angles involving the parallel lines.
Yeah, another pair. These red angles. The red angles.
Alternating.
Right, angles, yeah.
And here's another pair. Here's this one.
Right, yeah, I already did it. Seth, already done.
And this one.
Been there, done that. There are
two of them.
That's right.
Two pairs.
That's right. Now, what's helpful here, I don't know if you noticed, what's always helpful, let me make it thicker, even though Seth doesn't like thick lines, but, whatever, is extending the lines. Extend the lines so that you really see it, because if you don't have the lines extended, it's harder to see the alternate interior angles. So that's a little thing to remember. Always extend lines. Makes things easier to see.
The two blues are not pairs of alternating interior
No, they're
angles.
Just extensions of the lines.
They're extensions, but the alternating interiors are due to these, cross the two red dots.
Yeah.
Yeah, but it's not fair that you extended these on this side, but what about?
Oh, yeah.
If you're going to extend lines, do it on both sides.
Yeah, you're right. I should have. Yeah. No, the reason why is because once you lock this, the answer is once you lock this, then the answer's done. Once you see that relationship, you can answer the question. You don't need this. You don't need these. You don't need those. It's good enough just to lock the 45-degree angles. Because you just need one pair of alternate interior angles. You don't need two pair of alternate interior angles to prove parallel lines.
Well, the two pairs, the respective angles of the two pairs are, well, if one pair of alternating interior angles, right, where they have another transversal. So the thing is that the alternating interior angles pertain to what's called a transversal.
Yes, you have to
And
have.
in this problem, there are two transversals.
I know.
One transversal is this one, this
Right.
one here.
Yeah.
And the second transversal is that one.
Right. Yeah. But all you have to do is prove one pair of alternate interior angles.
Yeah.
But notice that in order to do this problem, we needed to know we had to get this angle or this angle, right? One or the other. We had to get this angle. So we had to use the fact that the sum of the angles in a triangle is 180.
Yeah.
So
well, a way to think about this is suppose is the thing. Yeah. Let me draw a diagram. The new diagram you have. Suppose a line like this, fixed line, right? And then you have two transversals, right? Now, okay. Now, see, I'm going to draw purple. Do we have purple? Yeah, purple for variable line, right? One possibility, is so you might have so we have three lines, right? The fourth line might be like this, or it might be like this, or it might be like this. Well, these three different lines. So you need the angle. What distinguishes these three different lines is the different angles that they make with one of the transversals. Okay. So if this angle, let's call this angle A. Let's call that angle A. And
Seth, what are you trying to do?
Nothing, not much.
Okay, so
I'm trying to undo this. If this is angle A and this is angle A prime, this is angle. These different angles determine different slopes of the purple line.
Okay.
So you need to know something about. You need to know the value of the angle at A, say, relative to the angles of the bottom line, in order to tell whether the top line and the bottom line are parallel.
You sound like you're just making it really more complicated than it is. Or you're just extending.
I'm trying to make it explicit what it is. It's the same. It's not more. So that we understand what you're getting at.
You're getting at that if you have two lines and you have a transversal and the alternate interior angles are congruent, then the lines are parallel.
Yeah, but the thing is, part of the problem is the first step in the problem was detecting that the two alternate interior angles were equal.
Exactly.
Yeah.
Exactly. That's why I wrote this thing, and this is very common in what's known as sort of an angle puzzle or a geometry problem. You have to know you have to use three principles. 1, 2, 3. You have to know you have to know and apply all three. If you miss one, then you're not going to get the problem. I'm going to make a mess. This is where we use the verticals. This is where you figure out this is the sum of the angles 180. That's how we got that. And then, of course, the final thing, parallel lines. Then the final thing is when we conclude that A is the answer. So this is very common in geometry problem, is that you have to know you have to usually know more than one thing, and you have to usually apply more than one thing. Okay? Anything else before we check the answer? Okay.
We'll give it a shot.
Yeah, let's give it a shot. So let's clear the mess. Go like this. This is here. Let's see how they do it. Okay. Let's see how they answered the question. 5 steps. Okay. Step 1, we have no information about the sides. That's right. So remember when I read the problem, I said, forget that one. Midpoint. There's no way it's a midpoint. We can't conclude it's a midpoint pretty easily, so leave that one for later. Vertical angles share a common vertex. Seth said, what are vertical angles? Those vertical angles share a common vertex. That basically, they lines intersect. Right, so that's why this question about vertical angles is impossible. The last choice is impossible because the angles aren't next to each other. In top, they don't share a common vertex. Since the angles are in degrees, the interior angles of a triangle sum to 180. They had to use that. Okay, and now, they used corresponding angles. They didn't bother. Okay, fine. So they skipped that. That's good of them. That's reasonable. They noticed that these angles are corresponding angles. And if they're corresponding angles, then the two lines are congruent, as opposed to what we did, which was just do the natural thing, which is to put a 45 here, and notice they're alternate interior. So, okay, fine. So they didn't use the vertical angles, but they used the corresponding angles. They didn't use the vertical angles equal to do the problem, but then you had to know corresponding angles equal, which is fine. So there, as you can see, there's more than one way to skin the cat in these problems. So, yeah, corresponding angles are congruent, and alternate interior angles, and also alternate exterior angles are congruent, which would make this angle here congruent to this angle here. Those are alternate exterior. So going into the test, the SAT, it's good to know all three. Alternate interior angles are congruent, alternate exterior angles are congruent, and corresponding angles are congruent. So they essentially did it the same way. Yeah. Okay. That's it, right?
That's all right.
That's enough. Okay, so I'm Joel. I have a PhD in mechanical engineering. Seth's here, brother Seth. Seth's my brother. He has a PhD in MIT, PhD in math from MIT. He's a professor emeritus at SUNY Albany, teaching computer science for many years, now retired. We're here hopefully to offer different approaches on how to do the math SAT problems. Very often, well, in this case, doing the problem as if you were in school and doing it on the SAT are almost the same. Use the same speed and approach, but we try to offer different approaches to the problems. And in terms of studying for the math SAT, approach we advocate is going to Khan Academy and taking either their digital or their non-digital SAT course, which has about 600 or 700 questions, which is sanctioned by the SAT people, and then go off and take actual SAT practice tests given by the SAT people. So please dislike our video. Please, comments are welcome. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. So that's it, right?
Yeah, that's it.
And that's it for today.
Goodbye,
Okay, everyone.
Everybody.
Take care. Have a good day.